Hi everyone, welcome to my channel Big Bang Chemistry, a complete solution of the chemistry. In the series of video lecture of some important topic, we are going to discuss today the Dragos Rule. Before going the depth of this rule, let's have some question answer session. And this question answer session will help you to understand this Dragos Rule. So first question, check that these are the hydrides of group fifth element. If I will ask you that what is the hybridization of central atom in these molecule, then simply you will count the total number of lone pair and bond pair of electron. You will say that the central atom of each molecule is sp3 hybridized. But this sp3 hybridized concept is correct for the nitrogen in ammonia, but it is not correct for the phosphorus, arsine, stibine in these molecules. If I will ask you that what is the nature of overlapping of NH bond in ammonia and pH bond in pH3 and ASH bond in ASH3 and SBH bond in SBH3. In ammonia you will say that this is what sp3 and S type of overlapping, but here if you want to say that sp3 S type of overlapping, it is not correct. Now question is why. Now third question, if I will ask which one is more basic, ammonia or SBH3? Based on your general assumption or general information, you will say that SBH3 is what more basic and NH3 will be what least basic. So if you want to arrange this in an order of basic strength, you will say that NH3 is less basic than the PH3, is less basic than the what ASH3 and then the what SBH3. But this order is not correct. Same question anyone can ask you about the hydride of group 16 element. This oxygen is sp3 hybridized, but this sulfur is not sp3 hybridized. This selenium is not sp3 hybridized. This T is not sp3 hybridized. Again question mark, why? This OH bond is formed because of the overlapping of sp3 and s orbital, but this bond is not like that. This bond is not like that. This bond is not like that. Lots of questions are there. One more important parameter if you want to check the bond angle. Once you will find the bond angle, this bond angle of H and H bond in ammonia is what? 106 degree 0.6. And then bond angle of these rest of the hydrides other than the ammonia, there is not a big difference between the bond angle. Again question is what, why? Same thing is there. The bond angle in water is 104 degree. In hydrogen sulfide is 92 degree. In H2SE 91 degree. In H2T 89.5 degree. See that these bond angles almost equal. Question is again why? What is the reason behind it? So answer of all the questions can be given with the help of Dragos rule. So what is Dragos rule? So what is Dragos rule? It is an empirical rule which helps to explain the bond angle of the hydride of group 5th A or 6th A, or you can say that group 15th or 16th element. But in these hydrides, the central atom must belong from third period and below the third period. So in these hydrides, when you will check hydride of nitrogen, hydride of phosphorus, arsenic and Sb, right, in these hydrides Drago's rule is valid. So what are the hydrides? So we can say that in pH3, SH3, SBH3, H2S, H2SE and H2T, this Drago's rule is valid. In what condition the Drago's rule is going to valid? So what is the condition? In which condition these hydrides will follow the Drago's rule? The condition is that the central atom must contain the one lone pair of electron. The second condition is that the central atom must belong from the third period and below the third period. Electronegativity of central atom must be less than 2.5 or equal to 2.5. And the percentage and sum of percentage of S character and P character must be equal to 100%. If these hydrides fulfill all four conditions, then in these hydride, the central atom or central atom orbital will not undergoes the hybridization. Meaning is that the covalent bond formed by the central atom of these hydride with the surrounding atoms will not involve the hybrid orbital. These covalent bond or sigma bond formed by the overlapping of pure atomic orbital. This is the meaning. Now question is that how it is going to form? Questions remain as it is. How in these hydrides central atom will not undergoes the hybridization, and why the central atom of these hydrides will use the pure atomic orbital for the formation of sigma bond or for the formation of covalent bond. To understand this reason, again cross check the experimental data related with this hydrides. So this is experimental data. Now check the experimental data. The bond angle in ammonia is this. This is the bond angle of phosphine. This is the ursine. This is T-bind. 91.34 is T-bind. Now check bonding nature of this NH bond or central atom or surrounding atom bond. Here is what? sp3. This bond, this sigma bond formed by the overlapping of sp3 and one is orbital. But in rest of the hydride, this sigma bond is formed by the overlapping of pure atomic orbital with the what surrounding s-orbital of hydrogen. Same thing is here also, same thing is here also. Same thing is here in oxygen. In water, the OH bond formed by the overlapping of sp3 and s orbital. But in rest of the hydride of the group 16th element, right, the bond formed by the central atom with the surrounding atom is not the overlapping of hybrid orbital, but again this sigma bond formed by the overlapping of pure atomic orbital. These are the what experimental data. Now question is that how to explain these observations. So these observations can be explained with the help of Dragos rule. So to understand this, let's assume that your any one of the hydrides, suppose pH3 is sp3 hybridized. Just assume it. Just assume that this pH3 is what? sp3 hybridized. And then we will do the what? Some qualitative analysis of this pH3 molecule, and then you can easily understand that why this bond is not formed by the overlapping of hybrid orbital, but this bond formed by the overlapping of pure atomic orbital. It is very easy to understand. Now let's check. Now let's assume that phosphorus in pH3 is sp3 hybridized. Just assume. And we know one more thing, how to calculate the percentage of S character and percentage of P character in a given bond. One formula we know that cos theta is equal to S by S minus 1. It is equal to what? P minus 1 by P. So we will use this formula to get an idea about the percentage of S character and P character in each bond of the phosphine molecule by assuming that it is sp3 hybridized. Now if this phosphorus is sp3 hybridized, so what is the conclusion? Conclusion is that in this the percentage of S character must be what? 25% if this is sp3 hybridized. So let's calculate it. So experimentally what we know that the bond angle of this phosphine is what? How much? 94 degree approx value. Just assume it. So by assuming this 94 degree, calculate the S character in this molecule, right? So cos 94 degree is equal to what? S by S minus 1. So this cos 94 degree value is what? 0.0697. So S by S minus 1 is equal to what? 0.0697. So S is what? 0.02. Meaning is what? What is the percentage of S character? 2%. Now check. If this phosphorus is sp3 hybridized, the percentage of S character must be what? 25%. But it is what? 2%. And according to your information and my information, none of the hybrid orbital having the what? 2% S character. None of the hybrid orbital. So what is the meaning of this? In this pH, in this phosphine, the pH bond is having 2% S character. What is the meaning of this? Meaning is that this phosphorus is not using its hybrid orbital. If 2% S character means what? The orbital used in the formation of this bond is what? 98% P character. Correct? So to understand this, let's check the electronic configuration of phosphorus. Electronic configuration of phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. And this is the what? Orbital arrangement of the electron. 3s2, this is 3p3, right? And this is the electron, and 3 unpaired electron present in 3p3 orbital. So based on this calculation, we can say that in this pH bond, S character is 2% and P character is what? 98%. Meaning is what? This phosphorus atom use their 3p orbital for the overlapping of this phosphorus atom use this 3p orbital electron, unpaired electron for the formation of sigma bond, right? So this is the what? Pure atomic orbital is going to overlap with the what? Pure atomic orbital of hydrogen, right? So from this discussion it is clear that here is what? This sigma bond, this sigma bond, this sigma bond formed by the overlapping of 3p s orbital, this sigma bond formed by the overlapping of 3p s orbital, this sigma bond formed by the 3p s orbital overlapping. What about the lone pair? Now check. This phosphorus atom do not touch its lone pair of electron. Meaning is what? This lone pair of electron belongs from the what? 100% or 98% s orbital. From the configuration, compare this. Now we know that the penetration effect of s orbital is what? Maximum. Correct? So now this lone pair of electron present in s orbital. S orbital means what? Very near to the nucleus. Near to the nucleus means what? Very strong force of attraction will pull this lone pair of electron towards itself, towards the nucleus. So that's why phosphine want to lose the electron, want to donate the electron, but phosphorus cannot donate its electron because this electron is present in s orbital. That's why phosphine is what? Weaker base than the ammonia. And this trend will continue to the next hydride after the phosphorus. So now from this discussion, it is clear that in the phosphine, phosphorus do not undergoes the hybridization. And this s electron, this lone pair of electron is present in s orbital. In that orbital, the effective nucleus is what? Maximum. And because of this, this lone pair of electron cannot be donated by the phosphorus. So it will not behave like a Lewis base, very weak Lewis base. So what is the now correct order for the basic strength? So based on this discussion, we can arrange these hydrides in increasing or decreasing order of basic strength. The correct order will be what? Ammonia is a stronger base than the pH3 and it is a stronger base than the what? ASH3 and SBH3. Same thing is there. Water is a stronger base than the H2S, than the H2SE, than the H2TE. Now, one more experimental evidence if you want to check, then you can check. Simply when you will give the hydrochloric acid to the ammonia, dilute hydrochloric acid, right? It will simply react and form the what? Ammonium chloride. But if you will take the phosphine and then you are providing the hydrochloric acid which is dilute, then this reaction will not occur. If you want to proceed this reaction, then you need to provide a strong acid. If you will provide the concentrated acid, then it will show the reaction and form the what? Phosphonium chloride. I hope that everyone is understanding that how and why these hydrides central atom is not undergoing the hybridization. In these hydrides, central atom is forming sigma bond because of the overlapping of pure atomic orbital. But in this case, in the case of water, in the case of ammonia, the sigma bond form by the overlapping of hybrid orbital with the surrounding atoms.